Hello, YouTube. Today, let's look at the leetcode80, remove duplicates from sorted array 2. So we're given a array, and it's a sorted array. We need to remove the duplicates in place such that each unique element appear at most twice. So we also need to keep the order after we remove it. The returned value should be k, which is equal to the length of the removed array. So I have seen a couple of YouTube video try to tackle this problem, but myself, I feel some of the explanation is not that easy to understand. So I came up with my own solution, which I think, at least to myself, is easy to understand and follow the logic there. So I want to share this with you guys. Hopefully, this will be helpful for someone who has the same problem as I am with the other solution. So the solution I'm gonna share with you guys, I ran it on LeetCode. It's actually gave these 49 milliseconds, and it beats 78% of the uh, submitted result. So it's actually pretty okay. So without overdue, let's jump to the content. Okay, let's look at the solution here. The algorithm we use here is a two-pointer algorithm. That's a common algorithm to solve array-related problem. We have an I pointer, that's the iteration pointer, and then we have a J pointer that is used to mark the last valid elements in the array. If we look at the example here, assume we are given a array 1, 1, 1, 2, 2, 3. The expected output would be 1, 1, 2, 2, 3, and we don't care about the last elements. So basically, the operation remove the third one here because that's violate our maximum number requirements. So if we look at exactly how this algorithm works, in the beginning, we will have a J pointer pointing here and I pointer pointing here. Because when we look at the first elements, we know for sure that the first element is valid because it's less than 2. So it's safe to let the J pointing to the first one to mark this is the valid element. And then I it points to the next elements we're going to check. So if we look at here, this value is 1. So that actually make the total number of 1 equal to 2. And that's still valid. So with that, we can move J to here and then proceed I to the next element. When we see the next elements here, we notice, okay, now we have a 3, 1 that valid our maximum number requirements. So we can't move the J forward. So we can proceed with I only. And here we see a new number, so that reset the counter. Now we have a number 2, and the number of this new number is 1. So that's actually make this value valid. So in order to achieve the result we want here, we have to move these elements to this place to replace the 1 here. And so it will look, after this operation, it will look like here. So and after we do this assignment, then we could actually move the J here to mark it as a valid element. Then we proceed with I moving to here. So in total we have a 2, number 2, so that's still valid. We need to do this assignment again to move this 2 forward and move J forward as well to mark the valid elements here. And after that, we proceed with I again. I reaching the last element here. That's a new element, so it's a valid. we actually need to copy it, do the assignment here to assign to this position, and after that, we could actually proceed J to mark it as a valid. So after this, basically we are done with the whole string, and then the algorithm is complete. Okay, now let's look at the source code. Um, I start this function by checking the corner case. So first, I want to make sure that if the input of array is the length of that is less or equal to two, I simply return 2, and the array is untouched. This is because with that, it will satisfy our requirements anyway, so we don't have to do anything. Then after that is the initialization. As we mentioned before, we're gonna put j here and I here. So the j pointing to the first elements as to mark this is a valid element. So that's why we assign this value like this. And we have a two variable. One variable is to save the current number, and the other is to save the count of that number. Here is the main loop. First, we check the number I point to. For example, in this case, we check this number and then we compare with the current value, which is 1. So if that's the same, it is, for example, it's actually in this case, they're the same, then we increase the count by 1. If it's not the same, let's like the situation here, when I reaching to 2, we simply reset the counter and change the current value to this new number, to 2. After that, we're gonna check if the count of this number is less or equal to 2. If that's the case, that means the element is still valid. If it's not the case, if that's not the case, then it's not valid. We only move j forward if this element is valid. For example, when the I come to this point, the total count will be equal to 3. In this case, we are not moving forward j. We keep the j in this old place. So this checking is just to make sure that happen. And then this line is the assignment we mentioned before. We want to copy, for example, in this case, when 2 is valid and 1 is not valid, we actually need to copy it over here so that all the valid elements will be in the beginning part of this array. So this is achieved by this line. And the last line is basically the iteration of the index I. When we finish the whole array, the requirements want us to return the length of this valid array, but the j is actually pointing is the value of the index. So we have to use the index plus 1 to return the length of that. So this is actually the whole algorithm for the result. Okay, thank you for watching. See you in the next video. Bye bye.